Okay, this is part 2 of graphing parabolas with the parent function, and this is factored form, also called intercept form. So we've been solving quadratic equations in factored form and factoring quadratic equations. So this might remind you of an example of a quadratic equation in factored form. And then if this was equal to 0, we'd solve that and you'd say x equals 3 and x equals -4. Well, these are then your x-intercepts. So in general, those are your p and your q in the factored form equation. So our x-intercepts are also known as our solutions to our equation, and we can also call them our roots or our zeros as well. So in factored form, p and q are x-intercepts. Then a, our leading coefficient, tells us that if it opens up, it opens down, if it's more wide or if it's more narrow, similar as in standard form. So let's graph a couple parabolas in factored form. So the first thing you need to do if you're going to graph a parabola in factored form is decide which way the parabola opens. So this one has a negative out front here, so this will open down. That negative is our a value, and it represents a -1 out front. Now to find the x-intercepts, you want to solve for x. It's like when x equals 0, so where does x equal 0? And we solve for x, we'd say, well, if x minus 2 equals 0, that means x would equal 2, or x plus 4 can equal 0, so x would equal -4. So these would be my two solutions. And so my x-intercepts are the points 2, 0, and -4, 0. So I would start by graphing those x-intercepts. So at 2, 0, and -4, 0. Now to find the axis of symmetry, we have to remember that parabolas are symmetric. And if these are my x-intercepts, those are the outsides of the parabola. So the axis of symmetry really has to be halfway in between this. And so just by looking at it, I can tell that my axis of symmetry is going to be at -1. This is a fourth example I've done where my axis of symmetry is at -1. I don't know why I keep choosing problems, but I promise that the axis of symmetry is not always -1. So with the picture, it really helps us see where the axis of symmetry is. Algebraically, you could find it by taking your x-intercepts, adding them together, and dividing by 2. You can do that by doing -4 plus 2 divided by 2. You'd get x equals -1. So that's our axis of symmetry. Now to find the vertex, it's similar to when we found the vertex in standard form. We know that the vertex will be on the axis of symmetry along this line somewhere. We just don't know exactly where. But all of the points along this line have the same x-coordinate, x equals -1. And so we're going to plug in -1 for x and solve for y. So I'm going to zoom out just a little bit so I have some extra space to do that. My equation is y equals -x minus 2 and x plus 4. So I'm going to plug in -1 for x. This negative out front is like a -1. Then that'll be times -1 minus 2 times -1 plus 4. So that's going to be -1 times -3 times 3. Now this -1 out front that we have, only multiply it by the first one. Don't distribute it to both. This is just a string of multiplication. So just do -1 times -3, that's 3. Then 3 times 3 is 9. So my vertex is going to be -1, 9. So I'm going to zoom back in to graph that. So I have my work over here from where I found my vertex. And my vertex is going to be -1, 9. So that's going to be up here. And then I can use my parent function pattern to help me find more points on the parabola. I know that my parent function has the pattern of 1, 1, over 2 up 4, over 3 up 9. This one has an a value of -1. So instead of going over 1 up 1, I should be going over 1 down 1, over 2 down 4, over 2 down 9. Then I cross out that middle column just to remind myself that I don't want to use that column. I want to do over and then down. So from my vertex, remember to start back at the vertex every time. That's your new origin. So it's over 1, down 1, reflect it over, then go back to the vertex again, and then go over 2, down 4, and reflect it over, and over 3 from the vertex, and down 3 is going to be our x-intercepts that we already have graphed there. And then I like that pen color. We can make our rainbow parabola. All right, so I have one more example just to show you if I can get this to move down here. This one is where we have a half, x minus 2, and x plus 6. So this parabola is going to open up because we have an a value of 1/2. It's positive. The 1/2 tells me it's going to be wider than the parent function. The standard width is just 1. So this one's going to be wider. My x-intercepts are going to be when I solve for x. So if x minus 2 equals 0, x equals 2. If x plus 6 equals 0, x equals -6. My x-intercepts will be 2, 0, and -6, 0 then. So I'm going to start by graphing those. And my axis of symmetry will be halfway between that. So it'll be at -2. Finally, an example where my axis of symmetry is not -1. So my axis of symmetry is at -2. Remember, you can always add your x-intercepts together and divide by 2 to find that if it's not as obvious, or maybe it's at 1.5 instead of 1 or a whole number. So that's one other way of finding it. Now to find the vertex, you take that axis of symmetry and you plug it in for x. I'm going to do that in a different color down here. I'm going to have y equals, going to be 1/2 times -2 minus 2 times -2 plus 6. That's going to be 1/2 times -4 times +4. Well, 1/2 times -4 is -2, and -2 times 4 is -8. So my vertex will be -2, -8, which is right here. Then I can use my parent function pattern, 1, 1, over 2 up 4, over 3 up 9. Since it's a half this time, instead of going over 1 up 1, I'm going to go over 1 up 1/2. I'm multiplying this by 0.5. Times 4 times 0.5 will be 2. 9 times 0.5 will be 4.5. So I'm using this pattern now instead. So from my vertex, over 1 up 1/2, do the best I can there. Over 2 up 2, reflect it over 3 up 4.5, and then I also have my x-intercepts there, so those will help guide my drawing of my parabola here. There we go. Now this also asks me for my x-intercept, so I'll find that for us as well quick, or the y-intercept I mean. Remember that the y-intercept is always when x is 0. So we just need to plug in 0 for x and solve for y. So that'll be 1/2 times 0 minus 2 times 0 plus 6. Plugging in 0 for x into my original equation. So that's 1/2 times -2 times 6. It's -1 times 6. It'll be -6. So my y-intercept should have been at 0, -6. Which it was right here, 0, -6. So, okay, that covers it for factored form, 2 examples. Hopefully that's enough. Otherwise, come and see me. Thanks, guys.